going to hit the record button. So we'll be recorded for posterity. And I'm going to start my video so I can go ahead and open up screen share. Hopefully you're seeing a picture of Mars and the Mars rover in the foreground. If you could give me a thumbs up if you see the picture, or say yeah, I see the picture, please. Okay, thank you, Paige. Appreciate that. Okay, here we go. Oh dear. There it goes. Now, are we hearing audio? Okay, good. Excellent. So we're seeing the entry, descent, and landing of the rover Curiosity, which landed successfully on Mars 7.5 years ago. The reason we're using Curiosity's footage is because Perseverance is going to land very much the same way. Now, in this image, Mars looks hot. It looks like every desert you've ever seen on Earth, with that red atmosphere or that salmon-colored atmosphere and the heat coming off the heat shield. Well, Mars is actually a lot colder than Earth. It's about minus 100 degrees from wherever you are on Earth to that same part of Mars in general, that same time of day. So what we're seeing here is the friction ablating part of the heat shield off. And the most important function the heat shield has is to protect the rover, which is tucked inside the seed pod looking thing, and to slow this thing down. Once the parachute is deployed, the heat shield can be cast away. And the parachute, of course, functions to slow it down even further in the Martian atmosphere. And the rockets, of course, slow it down even more. While the landing radar is looking for a safe place to land. With the landing camera looking at the ground. Scattering lets the rover down. The rover actually lands via surface. Now, all of that is the hardest part of this mission, or any mission to Mars. It's called by engineers at NASA the 7 minutes of terror, because a lot of things can go wrong in that whole sequence you just saw. So all of that has to go right in order for a lander to land safely on Mars. That sundial that you're seeing right here is also a color calibration tool. There's green, red, yellow, and blue in the corners here. It's a color calibration tool for the cameras, so the cameras can shoot more precise color images to get a truer picture for what Mars really looks like. The gnomon here, the stick, measures shadow length, so you can tell time of day on Mars from the sundial that's on Mars. And this is inspired by a design by Bill Nye the Science Guy. So Bill's sundials have flown now on 4 different, or will be flying on a total of 4 different missions to Mars. Spirit and Opportunity, Curiosity, and now Perseverance, because there's one on Perseverance as well. So it drives on Mars, and it comes up against this cliff that it can't climb safely, or they're not sure if they want to climb it or not. So detailed pictures come back, then the target is chosen, and the laser gets to work. Now, why do you need a laser on Mars? If you look at Mars, it's all basically the same color in this image. That's because Mars is mostly covered with rust, iron oxide. And there's a thin layer of iron oxide on most of the rocks and deposits that are on Mars. So in order to get underneath that rust to find out the real story of the rocks, you got to do one of 3 things. You can go up and you can grind the rust off, grind the top millimeter or so off. You can drill through it to get to a core sample of the rock underneath, or you can shoot it with a laser, which I think is a pretty cool instrument right here. So there's the target. And then it shoots a rock-burning laser to cut through the rock, and then a spectrometer aboard the rover analyzes the minerals underneath. It's going to take several shots here with the laser, and then decide it's going to come up closer to one of the samples for drilling analysis. This scene I call a bad day at the dentist. For obvious reasons. So shaking up the sample a little bit. And it's going to deliver the sample to the science lab inside. So there's 3 or 4, I think 4 science experiments that can use the sample that's been acquired by the drill. This is an X-ray spectrometer here. It's going to examine a thin section of the sample. Now those deflections of light, you can see the beam going straight through. The deflections, how far they're deflected off of the main beam, can tell you what elements and minerals are in the rock sample. There's a specific deflection for different minerals. A chemotype might be this one right here that keeps on repeating, for example. The Curiosity has driven about 12 miles on Mars and still drives today. And the biggest difference with the sample collecting bit is that the sample collecting bit will also deliver samples to tubes, like test tubes, on Perseverance. And Perseverance will actually be collecting about 40 Mars samples for delivery back to Earth in a future mission, probably in 2024. And that's about top speed for the rover. Because as it's driving, it uses cameras and software aboard its computer to decide the safest course on Mars. So it doesn't just drive willy-nilly across Mars, it drives in a very specific, safe pattern.
It's a whole planet out there with a complicated history. That history is a story that's stored in the rocks. And our job is to figure out that story and what that story of that planet tells us about this planet.
Recommendations of the Science Definition Team to NASA are to fly a rover of similar capabilities to the Curiosity rover that's still on Mars, that would land in the same way and have about the same size. And we are recommending that they equip that rover with instrumentation that allows it to explore the surface of Mars at one site, which will have relevance or importance to understanding past habitability, did it have the conditions necessary to sustain life, and to look for signatures or rocks that may hold signatures of biological significance.
So where Curiosity takes rocks and grinds them up into powder and looks at their bulk constituents, what this mission would need to do is be able to look in a microscopic level and examine the rocks for these very tiny and detailed messages that they would be sending to us about the past life that could have lived there.
So the sorts of evidence we're looking for, sorts of signatures of past life that we would be looking for would be signatures of microbial life. So not realistically looking for dinosaur bones and that kind of thing. If life ever existed on Mars, we expect it to have been microbial, microorganisms.
This that I'm holding up here is a classic biosignature from the Earth. It's a fossil. We're not actually expecting to see a fossil of shells or other components, but what we want to be able to see are, with this instrumentation, are the fine scale layering that one might see in a rock, in which we can see dark and light tone layers. And those dark and light tone layers are telling a story.
We wanted to do something that would make technical progress, and that thing was going and coring rock samples, putting them in a little container, a cache, and storing them for bringing back later.
Because no matter how well instrumented a rover is, we can't look with the kind of detailed understanding that we would have in laboratories back here on Earth.
We can do so much more in the laboratory on the Earth with equipment that exists now, and who knows what's going to get invented in the decades ahead that can still analyze those rocks.
The human flight component would like to see an experiment where resources on the surface of Mars, from the rocks or the atmosphere, could be used to generate fuel or other parts that would enable future exploration in cutting the tie, so to speak, to Earth. So you wouldn't necessarily have to bring everything with you. You can actually manufacture it on the planet. And
there's an instrument aboard Perseverance called MOXIE. And MOXIE's job is to take carbon dioxide, which is what the atmosphere of Mars is made out of, and turn it into oxygen, breathable air, basically, for astronauts who may be coming to Mars later. So it's an engineering design experiment to see if, in fact, oxygen can be generated from the atmosphere of Mars.
that's a really exciting additional component that we've been exploring and analyzing in this work.
Now, the next experiment we're going to show you about is another engineering concept design. and it's flying aboard Perseverance. And this is by far the coolest instrument aboard the rover. So the rover gets up to a place where it can't drive into. Now, the room that this helicopter is in on Earth has been vacuumed out, so it matches the atmospheric pressure of Mars, which is about 1% Earth's atmospheric pressure. So they wanted to see if the helicopter can fly in the Mars-like environment before you send it to Mars. NASA does some pretty cool stuff. And this probe is going to land February 18th of next year. The Perseverance rover is going to land in February 18th, 2021 at about 3 o'clock in the afternoon Eastern time. So perfect timing for landing events and things like that. I know I'm going to be planning on the course. But this helicopter is slated to fly in May of next year. So after the rover has done its first couple of sampling trips and it's got its regime and routine worked out, then it's going to deploy the helicopter, and they're going to do about 3 weeks of helicopter testing in May. Now the helicopter has solar panels up here, which will act to recharge the battery for the rover, for the helicopter. So are there any questions about Mars or Mars exploration or anything like that before we talk about the night sky? If you want to, you can either unmute your microphone or type something up in the chat. Either way, I'll get it and answer it. So I'm going to ask you a question that I'd like you to answer in the chat, please. And that is, why do we bother going to Mars? What for? What's the point? So I'm going to open up my chat window. And you can be brief. 1 or 2 sentences will do it. Please. We like the challenge. That's very true. We explore because we can. Mars is not easy. About half of the missions that have gone to Mars have failed. So yeah, Mars is hard. So it's a worthy challenge. And of course, we're curious to find out if life happened more than just here. All right, what I'm going to do is I'm going to stop sharing my screen for a minute, reshare my screen, except this time we're going to pull up a program called Stellarium. Now, Stellarium is a desktop software that you can actually use to model the night sky. And I've set Stellarium here for 9 o'clock in the evening tonight, because it's supposed to be pretty clear tonight. And I apologize about the jumping. My computer's processor is old and it's working very, very hard right now to render these images for you. So I'm going to close this window and close that. And if we go outside around 1 hour and 15 minutes after sunset, that's about 9 o'clock in the evening, we can look in the sky here towards the west. The sun went down here, right where this tree is. And if we look above the tree here, we see the planet Venus. Now, Venus is just about as bright. A couple of days ago, it was as bright as it gets. in the evening sky. So Venus is very bright, very easy to see. The only thing that competes with Venus for brightness is the moon. All these other stars here don't quite, aren't quite as bright as Venus is. Now this constellation right here that I'm circling with my cursor is Orion. And Orion is starting to get pretty close to the horizon and pretty hard to see. You might just barely be able to make out Orion's belt at 9 o'clock. And Orion's belt points to this bright star here. And you can actually compare Venus and Sirius. Sirius is the brightest star in the night sky. The only thing brighter than Sirius is Jupiter and Venus, the two planets. And we'll talk about Jupiter in a minute when we talk about the morning sky. But so I'm going to take you up to the north here. Hopefully bring the sky high enough where we can see the moon. Because the moon this time of night is high up in the sky. There he is. Coming there. So basically overhead at about 9:15 is the just past first quarter moon. So it looks like a half moon basically in tonight's sky, a little bit more than half. By next week at this time, the moon will be full, and the moon will be rising when the sun sets, because that's when the full moon rises. The full moon rises when the sun sets. So we're going to go here to the north, make for the horizon again. Now we're south-southeast, east, going to the north, slowly but surely. Okay, there's the north. Now I'm going to bring us up off the horizon here to catch this group of stars up here. That's called the Big Dipper. There's the Big Dipper. These 3 stars here that make a handle, and these 4 stars that make a bowl. And the Big Dipper is upside down this time of year. So it kind of looks like a 2-quart saucepan laying on the counter drying off. If you wash the saucepan and you're putting it on a towel on the counter to dry it off, that's kind of like what this looks like. And these 2 stars down here, the end of the saucepan, point to a very important star. And that star, conveniently located over the end for north, is called Polaris, or the North Star. And the North Star and the Little Dipper right here make up a constellation called Ursa Minor. The Big Dipper is part of a much larger group of stars called Ursa Major, which extends up here off the screen and extends a little bit to the front where it says stop video. So what I'm going to do is I'm going to put the sky in motion, and I want you to pay attention to the stars going around the North Star as we go forward in time here. I'm just going to speed things up a little bit. Notice how the stars make a big arc or circle around the North Star. There's Vega right there in the summer triangle, in the constellation Lyra. But as you can see, the Little Dipper was here, now it's up here, hanging down. And we're going to go to about, okay, come on. Stop. Please stop. Okay, my computer's processor is a little slow. We're going to back up time. Well, this never happens in reality, but we want to back up a little bit. Yeah, to about 5:30, close enough. All right, so I'm going to show you the Big Dipper here real quick. And then we're going to swing over to the eastern part of the sky. You'll notice the Big Dipper was up here earlier in the evening. Now it's way down over here. It's the handle and the bowl. And again, the bowl stars here are still pointing to the North Star. Now we're going to make for the east. Okay, and we go high in the southeast. And we see 3 planets. These 2 things you cannot see with your unaided eye. That's one thing I don't like about Stellarium. They show you stuff you can't see. But things you can see in the morning sky, again, this is around 5:30 a.m. You can see these until about 6 o'clock, and then it starts to get too bright in the morning sky to see them. There's Mars, Saturn, and Jupiter. They line up very nicely in a straight line. Mars is noticeably orangish red. So that's one thing that makes it easy to find in the sky, even though it's not as bright as Jupiter and Saturn. It's not as bright as Saturn, actually. But Jupiter's a lot brighter than both of them because Jupiter is bigger, and Jupiter is also fairly close to us. Mars is closer, but Jupiter trades off that closeness for its size. So it still looks bigger. Okay, my timer just went on, so we have about 9 minutes left. So are there any questions about this or any other facet of astronomy you've always been curious about? Now, coming up in a few days, I believe May the 4th, so May the 4th be with you, May the 4th is the peak of a group of meteor shower called the Eta Aquarids. And normally I wouldn't even mention them because it's a minor meteor shower, but apparently this year they should be pretty good. Unfortunately, the moon will be pretty bright in the sky until very late in the morning, around 3 or 4. And the thing to do with the Eta Aquarids or any other meteor shower is to go outside during the daytime and figure out where you're going to be at night when you're stargazing. Let's see this question in the chat. Okay. The name of the program we're using is called Stellarium. I'll type it out in the chat. And there's their website if you want to download the software and run it off your machine. It runs very nicely off runs very nicely off of any platform, whether it be Windows or Mac. With an older Mac, which is what I'm running with right now, MacBook, it uses a lot of my CPU's exchanging rate. But to go back to the meteor shower, go out anytime after midnight and find a good spot to lay down on, or bring a lawn chair out ideally so you're not directly on the ground. The stuff was crawling on out there, I don't know. I'm not a biology professor. I'm an astronomy guy. So I don't know what's crawling around out there. I don't want to know, so I bring a lawn chair. So that I don't have to answer that question the hard way. But you go out there, you lay out, and you stay out for at least 10 minutes so your eyes adjust to the dark. Unless you walk out in a dark house because you didn't turn the lights on. Your eyes have to adjust. Okay. So you want to go out for at least 10 minutes, look directly overhead. You should see at least 30 meteors per hour or a meteor every 2 minutes on average. But again, that's an average. Sometimes they come in spikes, just like those graphs we've all been looking at. Sometimes things happen in spikes, but the overall curve, the overall average is 30 an hour. Okay, so the Polaris star is magnitude 1.95, which means it's kind of bright, but it is not the brightest in the sky. It's important because of where it is. The Earth's North Pole points right at the North Star, or Polaris. And so as the Earth is spinning, it's spinning around that point in space. So stuff in the southern part of the sky, like your planets and the moon and the sun, all appear to rise in the eastern part of the sky, and then settle in the western part of the sky, or set in the western part of the sky. And that's all because they're actually making a big circle around Polaris. It's just that the circle's cut off by the horizons, so you don't see them. Polaris is actually a binary star. If you look at Polaris with a decent telescope, you'll see its dimmer neighbor. It's what's called an optical binary, which means they're not in orbit around each other. They just happen to be foreground and background to one another. Kind of like, putting up your thumb and seeing something in the background. Well, your thumb's not actually next to that thing in the background, but it looks that way. And that's what the Polaris binary is. All right. Are there any other questions about anything? We still got about 6 minutes, so we're good. All right. Well, I want to thank all of you for coming very much. Thank you. And I hope you have a wonderful day, and get out there and look at the stars and the planets at night or in the morning or both, because they're much more beautiful than anything I can do here, especially since we're actually running a real planetarium. The real planetarium, it gets better because you see the stars all over the sky in front of you, your head and behind you. And we'll be doing that as soon as the portable or the inflatable comes back. We should know that we originally ran out of a brick and mortar planetarium which flooded after Hurricane Matthew. And so each of the programs this coming week need their own Zoom meeting info to join. Okay, no, each of the meetings uses the same exact Zoom password and meeting information. So this will be in the same place. Now I have to tell you, this is also Tuesdays and Thursday show. So you don't want to hear about Mars again. You may want to skip Tuesday and Thursday. But on Monday, I believe I'm talking about the phases of the moon. And we have some excellent graphics to help me along with that. And also on Wednesday is about the Hubble Space Telescope. And then Friday is all about Pluto and the New Horizons mission to explore Pluto. So that is our programming schedule for all of May. So we're going to be doing that. I might change programs up as I start to get bored with them. You know, I think this Mars program will be one of the first to go because, you know, I'm going to watch it a lot. So, you know, it's not going to take too long for me to go, you know what, maybe I can do something else. So, you know, keep watching Facebook and our website because the programs may change a little bit, but that's the basic info for now. All right. So again, thank you very, very much for coming, and we will see you next time. Thank you.